My name's Hossam Fethi. I am an assistant professor of mechanical engineering at Penn State University. For a few years, have been running a lab called the Control Optimization Lab, cool for an abbreviation. It focuses on optimal control theory and its application to problems such as energy storage and management, including management of electrochemical batteries. Our focus is not so much on the fundamentals of optimal control theory, although we do contribute to the fundamentals. It is on the use of optimal control theory to hopefully make the world a better place by studying problems of significant practical impact like renewable energy generation, energy storage, the health management of energy storage systems, etc. The battery research area is a very important research area because of the degree to which energy storage, especially with improvement in power and energy capacity and density of different new battery technologies, lithium-ion and even more advanced technologies, these technologies provide the capability to revolutionize the way we deal with transportation challenges. We're beginning to see plug-in hybrid electric vehicles. We're beginning to see all electric vehicles take their place in the market.
So my name's Michelle Kays. I am just starting my second year of grad school here at Penn State. I went for undergrad here too, so I've been here a long time. And other than that, I'm a mechanical engineer. I've been working in the Control Optimization Lab for about 3 years now, first as an undergrad researcher and now as a graduate researcher. So one thing the Control Optimization Lab deals with is batteries. It's not the only thing, but it's definitely one of the things that we deal with. And I know I worked on a project where we were trying to develop models for these batteries. I worked on a project where we developed kind of simpler models, and then we found parameters for those models experimentally using the Arbin here behind me. I also worked on another project where we were developing more complicated physics-based battery models that can capture some of the higher order dynamics. I know other people in the lab are working on kind of cool control strategies to kind of identify parameters better, online applications to control batteries better, to get the most out of batteries. So there's a lot of different projects going on. One of the goals of the lab is to be able to make battery packs in cars last longer. So once the batteries are degraded too much, I think at about 80% capacity, it's basically thrown away. It's not good anymore. So there's a lot of different ways that you can extend that battery pack lifetime. One is that if you just are able to figure out which cells are bad, then instead of replacing an entire pack, you might just have to replace a couple cells, or you could just not use those cells as heavily. So there's a lot of different options there. And basically one of the main things the lab's working towards is making battery packs last longer. The stuff with batteries has definitely taught me that you have to be very careful, especially with doing experiments, just to make sure you're really organized and you're just really being consistent with everything. So that's really one of the important things it's taught me. I think one of the parts I like the best is doing research and then actually getting to publish it or getting to present at a conference about it. Because even though it's really tedious to write a research paper, in some senses it's cool that you've actually done something and you've done something new.